Hey everyone, and welcome. Today we're diving into a really cool new AI architecture called Engram. Now, the old way of making AI better was just to make it bigger. But Engram does something different. It makes AI smarter by giving it a cheat sheet, completely rewiring how it uses its brain to understand things like code.
So let's start with a kind of wild question. Is the AI you use every day actually wasting most of its time? It sounds weird, I know, but it turns out a huge chunk of an AI's powerful mind is spent relearning really simple, common stuff over and over again. It's like having to learn the alphabet from scratch every single time you want to write an email.
And here's the root of the problem. Unlike you and me, AIs don't really have a dedicated memory for quick lookups. Imagine if every time you needed to remember your own address, you had to pull out a map and figure it out from scratch. That's pretty much what AIs do. They're forced to simulate retrieval through computation, which is a fancy way of saying they use their expensive reasoning power to reconstruct simple facts every single time.
So what kind of simple stuff are we talking about? Well, researchers call them local, static, and highly stereotyped patterns. In plain English, that's common phrases like "for what it's worth," or famous names like Princess of Wales, or even really basic bits of code syntax. These things never change. An AI shouldn't have to think about them, it should just know them. Using its most powerful brain cells for this is just incredibly inefficient.
And this is where you can really see the difference. On the left, you've got your standard AI chugging along, using all that slow, expensive computation just to remember a fact. But on the right, an AI with Engram, it just looks it up, instantly. That's what O1 time means. It takes the exact same tiny fraction of a second whether its memory has 1,000 facts or 1,000,000,000. And this simple change frees up the AI's main brain to focus on what we actually want it to do: high-level, complex thinking.
So how do we get there? Well, that is exactly what Engram is designed to do. The best way to think about it is like giving the AI a cheat sheet, or even better, splitting the AI into two parts. You have the brilliant thinker, which is the main model, and now you've given it a perfect, lightning-fast librarian. The thinker doesn't have to memorize the dictionary anymore. It just asks the librarian, gets the answer in a flash, and can get back to the hard work of, say, writing a masterpiece. Okay, so let's put the official definition on it. Engram is what's called a conditional memory module. Its whole job is to take all of those boring, repetitive, static patterns and offload them from the main AI brain, the transformer, and stick them in a totally separate, super fast lookup system. It's a clean separation of duties. One part of the brain is for memorizing, and the other, more important part, is for reasoning. But how in the world does this AI librarian find the right piece of information in a library of billions of facts in a split second? Well, the magic is in a really clever three-step process using things called engrams, hashing, and gating. Let's pop the hood and see how it works. It's actually way simpler than it sounds. First, the system sees a short sequence of words. That's an engram, like our example, Princess of Wales. Then, a very fast math formula called a hash function takes that phrase and crunches it down into a unique number. Think of it like a library's Dewey Decimal Code. And finally, that number instantly points to the exact spot in a giant memory table where the info is stored. Simple, right?
Okay, but it's not quite perfect. There's this little problem called a hash collision. This is when that math function accidentally gives the exact same number to two completely different phrases. It's like two different books getting the same library code, so they have to share the same slot on the shelf. And, that sounds like a pretty bad bug, doesn't it?
Well, this is where the story gets really, really cool. It's a totally counterintuitive twist. Naturally, the researchers saw these collisions and thought, we've got to fix this. But when they ran the experiments to get rid of them, they discovered that this bug might actually be a feature.
This quote from the research paper says it all. Collision-induced noise may provide beneficial regularization. Now, regularization is just a term for anything that stops an AI from getting too rigid and overconfident in what it knows. And what they found was that this little bit of random noise from the collisions was actually a good thing. It was a healthy dose of randomness that they probably shouldn't try to fix.
So, the big takeaway here is that these accidental memory overlaps create a kind of controlled chaos. By forcing the AI to deal with a tiny bit of ambiguity, it actually learns to be more flexible and to generalize better. It stops it from just becoming a system that has perfectly but rigidly memorized a bunch of facts. It's a fantastic example of where a little bit of imperfection makes the whole system smarter. Okay, so we've got this really clever architecture, and even its flaws turn out to be helpful. But what's the actual payoff? What does this get us in the real world? Well, the performance gains are pretty eye-opening.
Let's start with general reasoning. On a standard benchmark, the baseline model scores about a 51. The model with Engram, almost a 56. Now, a 5-point jump might not sound like a lot, but believe me, in the world of AI benchmarks, that is a massive leap. It's proof that freeing up the AI's mind to just think really works.
And the improvements aren't just for general stuff. It gets way better at really logical tasks, too. For coding, it gets a 3-point boost. For math, it jumps up by almost 2.5 points. The entire model is just becoming more capable right across the board.
And this might be the most dramatic result of all. Check out its ability to find one specific fact inside a giant document. It's called the needle in a haystack test. The baseline model is about 84% accurate, but with Engram, that number skyrockets to 97%. Its ability to find exactly what it's looking for becomes almost perfect.
So why is all this happening? The research points to something called affective depth. Here's the analogy. Think of a student who already memorized all their multiplication tables. While other kids are still counting on their fingers, this student's brain is free to jump right into the complicated algebra. That's what Engram does. It gives the AI a head start, making its early layers as powerful as the deep layers of a much bigger, more expensive model.
And look, this isn't just theory. This technology is already powering the next generation of AI models, like one called DeepSeek V4. And that model has been built for an incredible task: to read and understand an entire software project at once.
What this really means is that we're on the cusp of a whole new era for AI in coding. When an AI can process over 1 million tokens of context, that's enough to read a whole code base. It can finally see the big picture. It can fix bugs that stretch across multiple files. It can remember the overall architecture of a project. We are fundamentally shifting from AI that just does code completion to AI that has genuine code comprehension.
And that leaves us with one last pretty profound thought. We've gone from AIs that can write a line of code to AIs that can understand entire systems. So if an AI can fully understand a complex, human-written code base, what's to stop it from building the next one all by itself? That's a question that could change everything about how we build software, and it might be answered sooner than we think. Thanks for watching.